About a project called CabTuRes, which is enabling autonomous sensors nodes with the help of tunable carbon nanotube resonators. This activity is an activity of 9 groups in EPFL, EMPA and ETHZ Zurich. Cosmin Roman actually receives one of the biggest portions of gratitude for coordinating this project. I'm talking about the integration of carbon nanotubes into systems. So we have a basic building block, which is the carbon nanotube between tips. We integrate this onto a system which includes a MEMS actuator. This is combined then with an integrated circuit to evaluate on the data. And this is supposed to be protected by a zero-level packaging. I have a picture included which shows you that we turn from cartoons into real devices. The reason why we actually develop these kind of platform technology for carbon nanotube resonators is that carbon nanotubes are actually excellent mechanical devices. They have a high yield strain, up to 5%. They are very nice electromechanical devices. They have high gauge factors, and they are in particular also lightweight, which results in high sensitivity if we talk about mass sensing. Having those kind of a platform technology available, which is the platform technology of resonating structures, then lots of applications become possible. For example, mass balances, as I already briefly mentioned, but also resonant force sensors, force microscopy. We can attach these sensors onto other structures, creating pressure sensors out of it, or simply strain gauges, and of course having a resonant structure which may depend on the environment. You will see it depends, may also allow to measure pressure of the atmosphere or viscosity of fluids around. We also have this electronic part in this project, which is needed to actually measure the resonance of these structures. We work on voltage-controlled oscillators or simply frequency detectors, and as a vision, maybe also tunable filters. So for the project itself, we focus on 2 aspects. First is the resonator aspect with a mass balance as a demonstrator, and we also develop electronic circuits to drive these resonating structure as an oscillator, knowing of course that the mechanical Q factors of those kind of structures are much lower than the Q factors of state-of-the-art MEMS devices, but we need to develop those kind of electronics to get used to evaluate on the data and develop the systems. So it's not per se just about miniaturization, but we are interested in this technology platform because we are interested in all of the benefits of miniaturization. And one of the benefits is that if we go to nanostructures, we can utilize low power drive electronics and low power applications based on these nanostructures. They do not take a lot of power. The regime is the nanowatt regime. But the question is simply what else? All right, I'd like to come to the results in the project, and as I already mentioned, 9 groups are involved in the carbon nanotube integration, Laszlo Foro and my group. For basic investigations on the carbon nanotube properties, Oliver Gröning and Wanda Andreoni from EMPA and EPFL. Mechanical properties of the clamps in the carbon nanotubes are investigated by my colleagues Brad Nelson and Dimos Poulikakos. Laszlo and myself, we also work on the integration of these tubes and the fabrication of the carbon nanotubes. A very important part with the continuous duration of the project becoming more and more important. The circuit development for the evaluation of the signal, Maya Kajal and Adrian Ionescu, and system package integration in collaboration with Nico Leroy. So, This is a technology integration project. The result will be 3-chip or 3-wafer stack integration. And during the last year, we worked actually on fixing and tweaking all these individual process steps to make them compatible to each other. For example, to make the through silicon interconnects surviving the 850 degrees carbon nanotube growth, or to make the passivation of the carbon nanotube contacts surviving the HF release of the carbon nanotubes. Just as I heard 1 hour ago, roughly, we have a preliminary process freeze achieved. So my group was sitting together during the lunch break and discussed this issue. Preliminary process freeze means, of course, we still tweak the individual processes, but we have fixed all these bits and pieces to make sure that all these individual parts fit together in a process flow. So we are now ready to release also a mask set or a design set for masks based on this process flow. Just 2 examples. One of these examples is a wafer bonding technology for a hermetic package of the carbon nanotube part by a glass cap. So the technology is gold silicon eutectic bonding. Hermeticity was achieved, and you see here a full wafer based on this technology as it will be applied for the system. So if you go to the carbon nanotube integration, then we developed a process flow to integrate those carbon nanotubes between tips in silicon. You see this mechanical arrangement with the carbon nanotube, which still has a slag, so which you may take as evidence that we need mechanical tuning capabilities to apply strain on these tubes. You see the side gate configuration, and you actually see also that this structure is acting like a transistor. It's a small band gap semiconducting tube, which is not turning completely off. But you see that there is gate influence on the current through the transistor. You see also that the deep peak of the Raman spectrum of the carbon nanotube is not present, which means these directly grown carbon nanotubes are very clean and supposed to be very good with respect to defects. As I said, we have options for a better carbon nanotube growth process than we currently apply, so this is supposed to be included. The oscillator circuit is preliminarily defined. A PCB board is available to start with the first measurements as soon as results from the currently released design set is available. We also have these basic investigations in the project, which help us to better understand how a carbon nanotube works and what we need to take into account if we design a carbon nanotube system. As I already said, if you are interested in further details, please consult the posters and talk with the PhD students, which are, most of them are on these pictures, and we'd like to thank you for your